So today we are going to discuss about complement of set. Okay, complement of a set. Okay, so what do you mean by complement of a set? Let us suppose U be the universal set. Okay, U be the universal set for a set A. Okay, then the complement of the set A is given by A complement. So A dash represents A complement, which is equal to U minus A. Okay, so A complement is also denoted as C on A. Okay, like this. Okay, so now you see, either you can write like this or you can write A dash in order to represent complement of A. So for example, suppose the universal set U contains 1, 2, 3, 4 and 5, and set A, and the set A contains the elements 1, 2 and 3. Then complement of set A is given by what? U minus A. Okay, how to find it? So what are the elements in set A? 1, 2 and 3. Those should be eliminated from the universal set. So what are the remaining elements? 4 and 5. So that's how we can find A complement. Okay, so now let us discuss some properties of complement of sets. Some properties of complement set. Okay, complement set. Okay, so first, complement laws. So what are the complement laws? Number 1, A union A complement is U equal to U. That means universal set. Okay. Number 2, A intersection A complement is phi. Okay, so let me give you one example. Suppose this universal set U contains 1, 2, 3 and set A contains 1 and 2. Okay, then A complement is given by U minus A, that's equal to set containing 3. Okay, so here you see these are the sets, these are the elements in set A, and so those should be eliminated from U to get A complement. Okay, so this is A complement. So now if you find A union A complement, then what you will get? So in order to find A union A complement, you have to write all the elements in set A and in complement of set A. Okay, so what are the elements here? In set A we have 1 and 2. In the set A complement we have 3. So this is equal to U. Okay, and A intersection A complement. Okay, if you find the intersection of A and A complement, then what you will get? You have to take the common elements in set A and A complements. Okay, so as you can see, if you compare these two sets, set A and set A complement, okay, then you can see there is no common element. So that's why it must be equal to 5. Okay, so these are the two complement laws. Okay, so next we get De Morgan's law. Okay, next we have De Morgan's law. So what are the De Morgan's laws? So there are two laws. Number one, A union B, complement of A union B gives intersection of A complement and B complement. Okay, and the next one is complement of A intersection B. Complement of A intersection B gives union of A complement and B complement. Okay, so let me show you with the help of example. Suppose U contains 1, 2, 3, 4, 5. Okay, and A contains suppose 1 and 2. Okay, and B contains the elements 3 and 4. Okay, so first let me show you the first property. Okay, so let us find first A union B. Okay, A union of A and B. A union B, that is what? That is a set containing all the elements in set A and B. That's equal to 1, 2, 3 and 4. Okay, that is A union B. Then what will be the complement of A union B? Therefore A complement of A union B must be the set, okay, set obtained by what? Eliminating all these elements in A union B from the universal set. Okay, that is 5. If you eliminate these elements from the universal set, then you will get 5. Okay, so this is the set complement of A union B. Okay, so now let's find intersection of A complement and B complement. Okay, so how to find that? So what is A complement here? This is set A, then A complements must contain the remaining elements after eliminating those elements in set A from U. Okay, what are the remaining elements? So in A we have 1 and 2, so ignore these two elements, then take these 3, 4 and 5. Okay, then intersection. Now B complement. So B contains 3 and 4. So eliminate 3 and 4 from the universal set, then what you will get? 1, 2 and 5. Okay, and intersection of these two sets means the set containing common elements in set A complement and B complement. This is A complement and this is B complement. Okay, so what are the common elements in these two? So only 5 we have, so that's why that's equal to a set containing only 5. Okay, now you see this is A union B. Okay, and this is the complement of A union B. Okay, which is the left hand side of this identity. Okay, which is equal to a set containing 5. Okay, and this is the right hand side of this identity. Okay, this is the right hand side so which is also results a set containing 5. Okay, so similarly we can so complement of A union B is also equal to union of A complement and B complement. Okay, so our next law is law of complementation, double complementation, sorry, double complementation. Okay, so what is the law? Complement of A complement gives A. Okay, so that means you can see there is double complementation. Okay, so suppose we have a universal set U which contains 1, 2, 3 and 4, and set A contains 2 and 3. Okay, so now you see how to find the A complement. A complement is given by U minus A. So how to find that? You have to eliminate the elements in set A from the universal set, and doing so we have got a set containing 1 and 4. Okay, now how to find the complement of complement A? That must be U minus A complement. Okay, then what to do? You have to eliminate the elements in A complement from the universal set, and doing so you will get 2, 3. Okay, 2, 3. Okay, so which is equal to the set A. So that's how we can show complement of A complement is nothing but A. Laws of empty set and universal set. Okay, so what are the laws? Number 1, null set, complement of null set is universal set, and the next law is complement of universal set is null set. For example, suppose we have a universal set containing elements 1, 2 and 3. Okay, and null set contains 0 elements. Okay, it doesn't contain any elements. Okay, so now complement of null set must give U minus 5. That means empty set. So as it is empty, so U minus 5 must give U. Okay, again complement of universal set must give U minus U. That's gonna be empty set. Okay, it's very simple. Hope you have understood this. Now we are going to solve the problems of exercise 1.5. So let us solve the problems of exercise 1.5 of Ncert textbook of mathematics class 11. Okay, so here is the first question. Here universal set U given for the sets A, B and C. Okay, so we need to find A complement, B complement, complement of A union C, complement of A union B, complement of you can say double complement of set A, then complement of B minus C. Okay, so let me show you how to find it. First, write the given sets. Okay, what are the given sets? Universal set U, which contains 1, 2, 3, 4, 5, 6, 7 and 8 and 9. Okay, then set A contains 1, 2, 3, 4. Then set B contains 2 4 6 8. Okay, then C contain 3 4 5 6. Okay, so these are the sets given. Okay, so now let's find A complement first. How to find a complement? A complement is equal to nothing but universal set minus set A. Okay, so what to do? You have to eliminate the elements of set A from the universal set. So what are the elements in set A? 1 2 3 4. So eliminate those elements from universal set, and remaining elements are 5 6 7 8 and 9. Okay, so this is the result, A complement. Okay, so now let's find the next one, that is what? B complement. Now we need to find B complement. Okay, let me show you how to find B complement. So B complement is similarly universal set minus set B. So let us find B complement. How to find that? Eliminate the elements in set B from the universal set. So what are the sets, what are the elements in the universal set which are the elements of set B? Those are what? 2 4 6 and 8. Okay, so let's eliminate those elements from the universal set, and doing so we will get here 1 3 5 7 9. Okay, this is what? This is B complement. Okay, hope you have understood. So now what is the next one? So in the next one we need to find, let me clean this first. Okay, so now we need to find complement of A union C. So before going to find it, first find A union C. Okay, A union C. So what will be A union C? A union C will be what? So just write the elements in set A and set B in a set. Okay, so 1 2 3 4 and C contains 3 4 5 6. Okay, so A union B will 1 2 3 4, then 5 and 6. So this is what? A union C. Now let's find A union C complement. Number 3, what to find? A union C complement of A union C. How to find it? Universal set minus A union C. So now what to do? Eliminate the elements in A union C from the universal set. Okay, sorry, this is the universal set. From this universal set, eliminate those elements in A union C. What are the elements in the universal set which are in the set A union C? So 1 2 3 4 and 5 6. Okay, these are the elements. Okay, in A union C. So eliminate those. Then doing so we will get 7 8 and 9. This is the complement of A union C. Then next, what to find? Next we need to find complement of A union B. So before going to find complement of A union B, we need to find A union B. Okay, so let's find A union B. Okay, let me clean this first. Okay, so A union B. So A union B means, so you have to write the elements of set A and B in one set. Okay, so 1 2 3 4. A contains 1 2 3 4, then B contains 2 4 6 8. Okay, 1 2 3 4. Don't write the same element twice. Okay, 1 2 3 4, then B contains 6 8. Okay, 6 and 8. Okay, so we have already discussed how to find A union B. Okay, so now let's find a complement of A union B. Now let us find this. Okay, complement of A union B. So number 4, we need to find complement of A union B. Okay, so how to find that universal set minus A union B. Okay, now eliminate those elements in set A union B from the universal set. So okay, this is the universal set. So 1 2 3 4 6 8. So what are the elements in universal set which are in the A union B? 1 2 3 4 5. 5 is not in A union B. Okay, 4 6 and 8. Okay, so let's eliminate those elements. Okay, then we will get 5 7 and 9. Okay, 5 7 7 and 9. So this is the resulting set, which is complement of A union B. Okay, that's how we can find complement of A union B. Okay, so let's find the next. Now we are going to find double complement of A. Okay, that is complement of A complement. How to find it? We know that A complement is U minus A. Okay, this is what A complement. Then complement of this is again U minus A. Okay, that will be U minus U minus minus plus, this minus, this is also minus, so that's why it is plus A. So that gives set A. So it's very simple. Okay, so hope you have understood this, how to find double complement of set A. Okay, so it's remember, it's you know, it's very simple thing. Just what to do, you see, double complement of a set is always equal to that set. Okay, so double complement of one set is always equal to that set, that is A. Okay, so what is the next? We need to find complement of B minus C. So first let us find B minus C. Okay, so let us find B minus C. Okay, B minus C is equal to, so how to find B minus C? Just eliminate the common elements of B and C, set B and set C from the set B. Okay, what are the common elements in set C and B? So here you can see 4 and 6, these are the common elements. Yes, 4 and 6. So 4 and 6, these are the common elements in these two sets. So when you find B minus C, then you will get, you have to subtract those or eliminate those elements which are common in these two sets from set B, that is 2, 8. You will get 2, 8. Okay, so therefore complement of, therefore the last one 6. Okay, complement of B minus C, that's is universal set U minus B minus C. So now what are the elements in B minus C? 2 and 8. So eliminate those two elements from the universal set. Okay, that then you will get, what are the elements in B minus C? 2 and 8. Okay, 2 and 8. So eliminate 2 and 8 from the universal set, eliminate these two elements. Okay, then you will get, what will be the result here? 1 2 is eliminated, 3 4 5 6 7 8 is eliminated, then 9. So this is the result. Okay, this is what complement of B minus C. Okay, so that's how we can solve question number 1. So now let me show you the next question, that is question number 2. Now let me show you how to solve question number 2. here the universal set is given, then we need to find a complement of the following sets. Okay, so I will show you only one from here. Okay, because these are almost same as question number 1. Okay, so now here you see number 1. So universal set is this A, B, C, D, E, F, G and H. Okay, these are the elements in the universal set, and set A contains A, B and C. So how to find a complement of set A? It's very simple. So just eliminate those elements which are present in set A from the universal set. Okay, so set A contains ABC, so eliminate ABC from the universal set, and doing so we will get a set containing D, E, F, G and H. Okay, that's how we can find a complement. Similarly, we can find B, C and D, complements of A, B, B, C and D. Okay, so hope you have understood it. So now let us solve question number 3. Taking the set of natural numbers as the universal set, that means the universal set should be taken as the set of all natural numbers, that is n. That means 1, 2, 3 dot 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 up to infinity. Okay, so this is the universal set for the following sets. Okay, so now what to do? Write down the complements of the following sets. So what is the first set? X such that X is an even natural numbers. Okay, that means complement of this set should be odd natural numbers. Okay, it's very simple. So you have to find the complement of this set, and this set is what? Set of even natural numbers. Okay, so complement of this must be set of, that means you can write X such that X is a natural number where X is odd. Okay, X is odd, or you can write X such that X is an odd natural number. Okay, odd natural number. Okay, so this is the complement of this given set. Okay, so now next set is X such that X is an odd natural number. Okay, this is odd natural number, that's why its complement should be what? Its complement should be X such that X belongs to capital N, that means natural number, where X is even. Okay, even. Or you can write X such that X is an even natural number. Okay, that's how you can find a complement of this set. Now next one, X such that X is a positive multiple of 3. Okay, positive multiple of 3. Okay, so that means complement of this set will be what? X such that X belongs to N, it must be natural number, as we have taken the universal set as the set of all natural numbers. That's why X such that X must belongs to N. Okay, where X is not a multiple of multiple of 3. Okay, so that is the complement of this set. Okay, now X says that X is a prime number. Okay, so X says that X belongs to N, where X is not prime. Okay, X is not prime. And the next one, X is x such that x is a natural number divisible by 3 and 5. Okay, divisible by both 3 and 5. Okay, so x such that x is a natural number, or you can write, instead of writing x is a natural number, you can write x belongs to capital N, which represent set of all natural numbers. Okay, such that x is not divisible by 3 and 5. Okay, 3 and 5. Okay, so now next one, x such that x is a perfect square number. So you can write complement of this set will be x such that x belongs to n. You can write x belongs to n where x is not a perfect square. Okay, is not perfect square. Okay, so this is the complement of this given set. Okay, the next one is x such that x is a perfect cube. So here its complement should be x such that x belongs to n where x is not a perfect cube. Okay, x is not a perfect cube. Now here you see, so x such that x plus 5 is equal to 8. So here x must be a natural number, because already it is given that the universal set is set of all natural numbers. That's why let's solve this in order to find the elements in this set. Okay, in this set, so let us solve this equation, x plus 5 equal to 8. So it should be x is equal to 8 minus 5, that's equal to 3. Okay, and that's equal to 3. So this contains only 3. Okay, so here its complement should be x such that x belongs to n, which is a natural number, but x is not equal to 3. Okay, where x is not equal to 3. Then so let's find the elements in this set. So here twice x plus 5 is equal to 9 given. So what will be the value of this? Twice x will be definitely 9 minus 5. 9 minus 5, that's equal to, x is equal to 4 by 2. Cancelling these two, we will get 2. So this contains 2. So complement of this set must be x such that x belongs to n where x is not equal to 2. Okay, so that's how we can write. So, or you can write, this can be written as also n minus set containing 2, like this also you can write. Okay, so now what is the complement of this set? Okay, so x such that x is greater than equal to 7, that means it is a set containing 7, 8, 9, 10 dot 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 up to infinity. Okay, so its complement should be what? X such that x belongs to n where x less than equal to 6. Okay, less than equal to 6. Okay, so because these elements should be eliminated from the universal set, which is the set of all natural numbers. And next one, x such that x belongs to n where twice x plus 1 greater than 10. So twice x plus 1 greater than 10, that means so twice x must be greater than 10 minus 1, that's why x must be greater than 9 by 2. Okay, so 9 by 2 means 4 and half. Okay, if x is greater than 4 and half, Then that means this set is what, as you can see, x is natural number and it is greater than 4.5, so this set must contain 5, 6 dot 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 up to infinity. So that's why its complement should be what will be its complement should be x such that x belongs to n, where x is less than equal to 4. Okay, less than equal. Now let us solve question number 4. Here you see this is the universal set, and this is set A, this is set B. Okay, using these three sets we need to verify these two relations. Okay, so let us verify the first one. Okay, so here you see, in order to verify this we need to find the A union B first. A union B. So what will be A union B? Find the A union B. So A union B is a set which contains all the elements of set A and set B. Okay, so here it will contain 2, 3, 4, 5, 6 and 7 and also 8. Okay, so now let us find the left hand side of this relation, that is complement of A union B. Okay, complement of A union B. So how to find this? Complement of A union B will be universal set minus A union B. Okay, so eliminate those elements from the universal set. Okay, so here you see, starting from 2 to 8, from 2 to 8, these all elements should be eliminated. Okay, then you will get 1 and 9 in this set, resulting set. Okay, now let us find A complement and B complement, then we can find the right hand side. Okay, how to find the A complement? Okay, let's find the A complement first. A complement is universal set minus set A. So in order to find the A complement, eliminate all the elements in set A from the universal set. So here 2, 4, 6 and 8, these are the elements in set A, so eliminate those, and set of the remaining elements is the set which is equal to A complement. So here 1, 3, 5, 7 and 9. Okay, this is A complement. So like that, let's find B complement. Okay, so how to find a B complement? Just eliminate the elements in set B. Okay, from the universal set. What are the elements? 2, 3, 5, 7. 2, 3, 5, 7. Then B complement must be, so as you see, B complement is U minus B, and eliminating the elements in set B from set A. So what are the elements? Here you see 2, 3, 5 and 7. So set of the remaining elements is the B complement. So what are the remaining elements here? 1, 2, 3, 4. Not 1, 2, 3, 4. 1, 4, 6, 8, 9. Okay, 1, 4, 6, 8, 9. 1, 4, 6, 8, 9. Okay, so now what to do? We need to find the right hand side of this relation. Okay, so let's find what is the right hand side. A complement intersection B complement. Okay, A complement intersection B complement. So this is the right hand side. Okay, this is the right hand side, so let us write right hand side. Okay, so in right hand side, what is there? A complement intersection B complement. So it is a set containing common elements in set A and A complement and B complement. What are the common elements here in these two sets? 1 and 9. Okay, so 1 and 9. Now you can see this is the left hand side and this is the right hand side, both are equal. So that's why, left hand side equal to right hand side. Okay, right hand side, hence verified. Okay, similarly you can verify this relation also. In order to verify this, first you need to find the A intersection B. Okay, which means it is a set of the common elements of in set A and B. Okay, so common elements in set A and B. Okay, let's find the common elements. So here you see, in the set A and B, 2 is common here, only 2. Okay, so this is A intersection B. Okay, then let's find A complement and B complement. So B complement and A complement already we have got here. This is what A complement, and this is B complement. Yes, this is the B complement. These two are A complement and B complement. So let's find the union of A and B complement. Okay, so before going to find it, let's find a result of left hand side. Okay, left hand side is A intersection B, complement of A intersection B, which means union universal set minus A union A intersection B. Okay, so how to find this? Just eliminate this element in A intersection B from the universal set. That is what, this is the universal set U, and this is the element which is contained in the set A intersection B. So that's why set of the remaining elements are 1, 3, 4, 5, 6, 7, 8 and 9. Okay, so this is the left hand side. Then right hand side. Okay, right hand side is A complement union B complement. So this is the right hand side, A complement union B complement. Okay, so we have already got A complement and B complement here. This is A complement and this is B complement. Okay, so just find the union of these two sets. So here it must be a set containing all the elements in A complement and B complement. Okay, so what are the elements here? 1, 3, 4, 5, 6, then 7, 8 and 9. Okay, 1, 3, 4, 5, 6, 7, 8 and 9. Okay, don't write the same elements twice. Okay, so here you see, if you compare the left hand side and right hand side, both are same. Okay, so therefore left hand side equal to right hand side, hence the given relation is verified. Okay, so that's how we can verify these two relations. Okay, hope you have understood this. Now question number 5. Draw appropriate Venn diagram for each of the following. So we have to draw Venn diagram representing those. Okay, so according to De Morgan's law of complement, here you see these two, complement of A union B is equal to A complement intersection B complement. Okay, so that's why first and second both will be represented by the same Venn diagram. Okay, number 1 and number 2, because you see complement of A union B is equal to A complement intersection B complement. Okay, this is De Morgan's law. So therefore these two will be represented by the same Venn diagram. So let me draw. So in order to draw the Venn diagram, first draw a rectangle here. Okay, this is the rectangle. Then let me draw two circles representing set A and another circle representing set P. Okay, suppose these two represent set A and set B, and this is the universal set U. Okay, so you see the area will be represented by you see these two complement of A union B. A union B represents the area inside these two circles. Okay, but complement of A union B will represent area outside of these two circles. Okay, so in order to represent, let me draw some lines here. This is shaded region. Okay, so this region will represent A union B complement. Okay, A union B whole complement of A union B equal to complement of A intersection complement of B. It is represented by the region, this region. Okay, so similarly, by the same law, De Morgan's law, complement of A intersection B is equal to A complement union B complement. So both of them will be represented by the same Venn diagram. Okay, so let me draw the Venn diagram. Okay, using white color. So again, let me draw a rectangle here and two circles representing set A and set B. Okay, suppose these two represent set A and set B, and this is the universal set. Okay, the whole rectangle represents universal set. Okay, then you see A intersection B is represented by the common region between these two circles. So complement of it will represent the remaining part. Okay, so here is the Venn diagram for complement of A intersection B. Okay, or A complement union B complement. Okay, represented by this shaded region. Okay, because you see, according to De Morgan's law, these two complement of A intersection B equal to A complement union B complement. Okay, that's why these two will be represented by this same Venn diagram. Okay, so here only this, you see, this common region is excluded. Okay, then remaining region is what? Complement of A intersection B. Okay, this common region is represented by common region represents between these two circles the intersection of A and B. Okay, and this part is not included. Okay, this part is not included, so that's only the shaded region is representing the complement of A intersection B. Okay, so let me clean this common region. Okay, now let us solve question number 6. Let U be the set of all triangles in a plane, and if A is a set of all triangles with at least one angle different from 60. Okay, so it is a set of such triangles at least one angle is different from 60. That means maybe more than one angles different from 60, but there should be at least one angle which is not equal to 60. Okay, so that means the complement of this set must be a set of equilateral triangles, okay, having no angle different from 60. Okay, so A complement will be equal to what? It is a set of all equilateral triangles. Okay, so that is the answer of this question. Now let us solve question number 5. Fill in the blanks to make each of the following a true statement. So here you see A union A complement. Okay, so you see A complement means universal set minus set A. Okay, then again, if you find A union A complement, then what you will get? Okay, then what you will get? Then you have to combine these two sets. Okay, you have to combine these two sets. Okay, the set not containing the elements of A, okay, and the set containing the elements of set A, then again you will get the universal set. Okay, it is a law of complement. Okay, it is a law of complement. Again you see phi complement is nothing but universal set. Complement of phi is universal set. So if you find universal set intersection set A, then definitely you're gonna have the universal set. So it is universal set U. Okay, then again A intersection A complement. Okay, so you see A and A complement are disjoint sets, so their intersection must be phi. Okay, these two sets have no common elements. Okay, and you see complement of universal set is phi. Phi intersection A is again phi, so it should be phi. Okay, so that's how we can solve this problem. Okay, this exercise is finished now.